Hi, my name is Ulysses Ordaz, and this is my project presentation for Advanced Embedded Systems for Winter 2021. My objective was to create a 3D scanner using OpenCV. Now, the reason I picked this project is because sometime last year I picked up 3D printing as a hobby. And I chose this project so I could produce work similar to what you see on the picture on the screen. So there are many methods of generating 3D images. So the challenge I chose was to generate these 3D images using OpenCV. But what exactly is OpenCV? Well, OpenCV, or Open Source Computer Vision Library, is a library of programming functions mainly aimed at real-time computer vision. Now, before starting the project, I had no experience with OpenCV or Python, which is the language I chose to put this project together. I did know a little bit about 3D printing, rendering objects in SolidWorks, and I have a good C and C++ background. I didn't know where to start, but after a brief consultation with Brother Grimmett, I found that I had to find a way to generate a point cloud. I had a few different tools at my disposal, but I ultimately opted to use an Intel RealSense D415 depth camera to help me with this objective. So with this in mind, I was able to put together two programs. They use a combination of OpenCV and an open source library available on the Intel website that allows you to access the depth camera's functions. And I'd just like to give you a live demo to show you how my project works. So I'll just give you a brief rundown of the project. First, we set up all the hardware functions of our depth camera. So we enable the camera, we enable the depth sensors. Then we have this while loop that consistently feeds the camera's output into an OpenCV generated window. And then we have commands we can give to our program once we run it. So we have Q to quit, E to generate a point cloud, and V to view said point cloud. Now, these are functions that are a part of the Intel RealSense camera. So we just access those using Python. And I'd just like to show you the output of the camera. To the right, we have the camera's depth map perception rendered in blue. And to the left, we have a real-time color rendering. So if I press E, it freezes up for a little bit, but after the ply file is generated, it'll start moving again. We press V, we can see the ply. And again, this part uses OpenCV to be able to view this ply file. So you can see, I'll take another picture from the front. Press V to view it. And there you go. The quality is pretty good for this version of the program. So the difficulty is that it is generated as a depth map. So it's kind of hard to tell what is what if you're working with multiple files. Then we press Q to quit. Now the second version of the program is a little bit more complicated because it uses a special algorithm that I'll go through later. But same as before, we activate the camera's depth sensor, we activate the camera. We have these functions to project our point of view at an angle, just so we can better tell what we're taking a picture of. And then we generated point cloud in color. So this specific algorithm, I got it from the Intel RealSense software development kit, and it just places that color in a UV light rendering onto the ply file you generate. And this program does generate ply files with a higher resolution. So same as before, we have our old commands: P to pause, E to export or create that ply file, V to view the ply file. So I'll just show you. Let's take a shot. Let's press E. And this one doesn't freeze up. And as you can see, the quality on these shots is much higher, and you can very well tell that's me. Let me take another shot at an angle. You can see me in greater detail. And this version, if you want, you press P to pause, like I mentioned, and it freezes up your point of view. You can press E to create the ply, press V, and it takes that freezed image and generates a ply file for that as well. I'm going to press Q to quit. We successfully exited. Now, one thing that this project falls short on is generating a render of whatever object you're taking pictures of in real time. But for that, we use this project called MeshLab. So with MeshLab, you take the plot files and you manually glue them together. So here I have the scan of my head. I took a few pictures of my head and then put them together using this program. Then we can export that into a STL file generator like Kira, and we can generate those files for 3D printing later on. So I'll just show you how the 3D printer will slowly print my head in this case. This has an application for many things. We could print out cars, we could print out figures, you can print out models of anything you would like to scan, as long as it's somewhere from a small to medium-sized object. I'd say somewhere up to a car is the safest we can go with scanning. And there you have it. Now, a few of the challenges I did run into was understanding the software development kit from Intel, but after getting the hang of it and how I could generate point clouds using the Intel RealSense camera, it really took a lot of layers of complexity away from my project. I did have trouble figuring out what to do with the ply files, but MeshLab took care of that issue as well. And it was very convenient that those ply files could be uploaded into Kira to later generate STL files that can be 3D printed. Some possible improvements would be to increase the size of the objects in the ply file. If you noticed, I had to zoom in a couple of times when I would take those pictures. And while uploading those 3D images in Cura, I get the error message that the images have to be magnified greatly. So that's a potential fix for the future. Another improvement I could add to it would be to generate a 3D render of the object in real time. So that way I could just avoid using other software to process my ply files aside from Cura to generate the STL file. And another thing I tried to implement but didn't work was to create a simple for loop just to avoid overwriting the output ply files. But it seems that this action isn't supported by the Intel software development kit. So I just went on with my project. Now, from this project, I was able to achieve my objective of generating these 3D images. I learned how point clouds are generated. I learned how to use OpenCV. I learned how to use Intel RealSense D415. I increased my knowledge of Python programming, and I feel the project was relevant to my career because I'm interested in going into test engineering and working with embedded systems and with Canvas, with cars. So I feel that learning about OpenCV would help me in this with self-driving cars and just computer vision used in vehicles and other applications. And with this video submission, I will include a link to the Intel library that I used to support myself and a GitHub with my projects. But I thank you for your time and thank you for your attention during this presentation. And I hope you enjoyed it.